Polymorphism in Python allows objects to be treated as instances of their parent class, enabling a single interface to represent different underlying forms. This flexibility is crucial for creating extensible applications, as it supports diverse behaviors across object hierarchies, enhancing code maintainability and scalability. Polymorphism allows a single interface to support multiple behaviors, crucial for building extensible Python applications. It enables objects from different classes to be treated uniformly, promoting code reusability and flexibility. This foundational concept in object-oriented programming ensures that software can adapt to evolving requirements without significant structural changes. Polymorphism, from Greek poly, many, and morph, form, allows a single interface to express multiple behaviors. It enables uniform treatment of diverse objects through a common interface, fostering generic code. This core principle is vital for creating flexible, reusable, and extensible Python applications that adapt seamlessly to evolving requirements. Polymorphism in Python simplifies code by allowing shared interfaces, eliminating the need for conditional logic. It supports dynamic behavior, executing methods based on runtime object types. This promotes loose coupling, easing system modifications and extensions. New classes integrate seamlessly, adhering to the open-closed principle, enhancing maintainability without altering existing code. Polymorphism allows a single function, like makeSound, to interact with different objects. A bird object returns tweet tweet, a dog object returns woof woof, and an airplane object returns roar of engines. This showcases how a consistent interface can yield varied implementations, highlighting the power of polymorphic behavior. Method overriding allows subclasses to redefine parent class methods, enabling runtime polymorphism. Python determines which method to execute based on the object's actual type. For instance, an animal class might define a speak method, while subclasses like cat and dog override it with meow and bark, respectively, showcasing diverse behaviors. Method overriding allows subclasses to redefine inherited methods, replacing original behavior. This enables runtime polymorphism, where Python executes methods based on the object's actual type, not its reference. For instance, an animal class's speak method is overridden by cat and dog classes, producing meow and bark respectively, demonstrating varied behaviors with the same method name. In method overriding, the base class animal defines a generic speak method. Subclasses like cat and dog override this method to provide specific sounds, meow and woof, respectively. The makeAnimalSpeak function demonstrates runtime polymorphism by executing the correct method based on the object's actual type, ensuring interface consistency while allowing unique subclass behavior.